In this lecture, we're going to discuss about the energy difference. As I taught you, energy is ability to do work. Now, today we're going to talk about the energy levels. There are two energy levels, E1 and E2. Now, suppose a nucleus. These are two orbits around the nucleus. Now, this orbit is referred as E2 and this is referred as E1. As I taught you that electron that is nearer to the nucleus has less energy as compared to the electron that is far from the nucleus. Now, we can define the difference between E1 and E2 by a formula. As we know that the value of the E is minus Z squared, charge, power 4, mass, 8 epsilon naught, N square and H square. Now we're gonna take the negative because we just know that the attraction force always termed as the negative, as the kinetic force is is nearer and the repulsion height is less. So we're gonna take the value of the E in the negative. Okay, so here is the negative value of E, another value of E. Now here is the symbol minus and the value of the E is also in minus. So minus into minus plus. Let's take all the constants common. Z is constant, E is constant, mass is constant, 8 is constant, epsilon naught is constant, H is constant. So remaining would be number of the orbits and the 1. So when we just sum up all the constants, the answer would be minus 2.178 10 raised to power minus 18. That's a constant value that does not changes. Now when we multiply it by number of the moles and then 1000, it will become 1313.35. Now here the value, and we're gonna just take this as the number of moles 1 and this as the number of moles 2, because we know that we have to find difference between two energy levels. So this is the formula to find the energy level of E1 into E2. Now let's calculate the energy levels of the fourth orbit and the third orbit. Now we know that the orbit that is nearer to the nucleus has less energy. So we will refer it as N2 and 4 as N1. After we know that constant, after multiplying and adding it, we're gonna have the answer of 45.86138889 kg per mole. This is the unit of the energy levels. So this is how we calculate the energy levels. Now with reference of the energy levels, we can also find out the delta of the energy with respect to frequency. How to find that? We're gonna just say take the value of the energy. Here's the value of the energy, and here's the full standard term of an energy. Now we have to equalize or equate it by the formula of the frequency. So by equating it, we know that this is the Planck constant and here we also have the Planck constant. So we're gonna just take this Planck constant to that and it will become Planck constant Q. Now by multiplying or dividing all the constants, we're gonna have the value 2906 10 raised to power 15. And when we got any problem of that we have to find the frequency with respect to energy, so we're gonna just apply this formula. As it is, we can find wave number, and we know that the formula of the wave number is so we're gonna just put this is the speed of light. We know that the speed of light is constant, so we're gonna just take the constant to other hand side, and we know that this is also constant, so we're gonna just take it on the other side, and that way we can find out the formula or the value or the standard form to find the delta E or find the energy. And that's all about today's lecture.